Hello, once again welcome to the 13th class of Software Engineering and Project Management. In the second module, we were discussing about requirement engineering process. In today's class, we will understand in detail about data flow model for the requirement analysis. During the requirement engineering process, various models can be developed. We know that requirement discovery is the process of gathering information about the required system and existing system. And finally, prototypes are normally used to help stakeholders to understand what the system will be like. Now, instead of this prototype, there can be different models: context level, behavioral model, data flow models, state machine models, object model, and structured methods are the different models or methods used for the requirement engineering process. Context model describe the requirements based on the boundary of scope for the project. Then behavioral model. Behavioral elements or the behavior of a computer based system can have a profound effect on the design that is chosen and the implementation approach that is applied. Therefore, the requirements model must provide modeling elements that depict behavior. Data flow model, we will discuss this in detail today. It is a method of showing how data is processed by a system on structured system. And data flow models helps analysts to understand the system. And there are different types of data models: top down process model, reverse, bottom up, etc. Another model is state machine model. We will discuss initially this state machine model. It shows how system states and events that cause transition from one state to another. State diagram is one method for representing the behavior of a system by depicting its states and events that cause the system to change state. Actually, a state is an observable mode of behavior. In addition, a state diagram indicates what actions, that is, process or activation, are taken as a consequence of a particular event. Another model is object model. Nowadays, object oriented to the whole software development model process is commonly used, particularly for interactive systems development. We have class based elements. We will discuss that example also today before discussing in detail about data flow models. So in class based elements, each usage scenario implies a set of objects that are manipulated as an actor interacts with the system. These objects are categorized into classes, that is a collection of things that have similar attributes and common behavior. Nowadays, for requirement engineering process, various structured methods are available with case tools. Case tools means computer aided software engineering tools. Case tools. For example, diagram editors are available, design analysis and checking tools are available, repository query languages, data dictionaries, report generation tools, form definition tools, code generators, etc. are available so that easily the requirement engineering process can be done nowadays with case tools. Before moving further, let me introduce another term, ethnography. Ethnography is an observational technique that can be used to understand social and organizational requirements. Whenever we do the requirement engineering process, whenever we analyze the requirements, ethnography is required so that the various other aspects, social aspects, other related financial aspects or other related aspects can be understood which may not be written explicitly as the requirement. During ethnography, that is to understand social and organizational requirements, the analyst need to immerse himself or herself in the working environment. The day-to-day work has to be observed, and we have to note the actual tasks that each user is involved in the system. The value of ethnography is that it helps discover implicit system requirements that reflect the actual ways that people work rather than the formal process defined by the organization. In the last class, we had discussed about use case diagram. Use cases is one of the technique of UML, that is unified modeling language, to model the requirements in object-oriented system. Hope you remember the simple use case for article printing. In the library system, the various use cases for the article printing with the various actors like library user, supplier, library staff were discussed in the previous class. We had mentioned slightly about object model. It is an object oriented model to the whole software development process, uh, for particularly for interactive system development. We had slightly mentioned about this object model today. So this diagram is the interaction involved in library system for downloading and printing an article. Four objects of classes are article, form, workspace, and printer, which are involved in the interaction. The sequence of interaction is from top to bottom, and the labels on the arrows between the actors and objects indicate the names of operations. Essentially, a user request for an article triggers a request for a copyright form. Once the user has completed the form, the article is downloaded and sent to the printer. Once printing is complete, the article is deleted from the library system workspace. So this type of sequence of interaction diagram helps the analyst to understand the requirements, to understand the objects, to understand how the system interacts. Such kind of things can be easily understood by drawing this kind of diagrams. Now the library system, the same activity can be represented in the object-oriented model with the class diagram like this. The various classes article, source, order, copyright, country, buyer with the details of each of this data model are represented. The communication between these data are represented with arrow marks, and thus the sequence of activities can be, or the system can be represented in the data model based on object oriented technologies. This is another type of UML diagram. We will discuss few important types of UML diagrams later in detail. In today's class, we are going to focus on data flow models. We know data flow model is a method of showing how data is processed by a system on a structured system. It helps analysts to understand the system. Though this data flow model is considered as outdated technique by few software engineers, still this model is continues to be one of the most widely used requirement analysis method. So let us understand this data flow model. We call this model with the help of we introduce this model with data flow diagrams. Data flow model is represented with DFD, data flow diagrams, in which it takes inputs, then the data will be processed and output will be generated. In the DFD, data flow diagrams, there will be some labeled arrows that represents the data objects. In the data flow diagram, there will be circles. That circles represents the process, that is the transformations take place on the data, that is computation takes place on the data. And in data flow diagram, the first data flow model is called level 0 data flow diagram, or another name is context diagram. Actually, level 0 and context diagram is different. We will discuss it on later stage in detail. Anyway, both are initial level data flow models. To learn data flow diagram, first we should be familiar with the data flow diagram symbols. There are two main types of notations used for data flow diagram. Jordan code, representation of data flow diagram. Gain-Sarson, representation of data flow diagram. Both people have used different symbols. Both symbols have represented here, and the meaning of these symbols such as entity, process, data store, that is database or file, then data flow notations, all are shown here in this diagram, in this slide. When we draw data flow diagram, there are some rules and tips to be followed. First rule is that each process should have at least one input and one output. Similarly, each data store should have at least one data flow in and one data flow out. The data stored in a system must go through a process, and all processes in a data flow diagram go to another process or a data store. Let us understand the process. We are using Gain and Sarson's symbol for representing process here. The process is the work or actions performed on data. That is, inside the system, what is happening will be represented through the process. Here, the process is producing the grade report. There will be one input, that is, input data is grade detail. It will be processed. Then output data is grade report. So here, the label inside the process should be a verb phrase. Remember, here it is written as, note here it is written as produce grade report. It is a verb phrase. And it receives input data, grade detail, and produces output, that is grade report. A process can have more than one outgoing data flow or more than one incoming data flow. This is shown in this diagram. A process can connect to any other process as shown in this diagram. Can you tell which is the correct process representation in this? In the first one, there is one input and there is one output, so process generates something. Okay. In the second one, the process generates policy number, payment amount, but the process do not generate any input data. So the second diagram is incorrect because it do not receive any input. Then third diagram, It receives all inputs, but after the processing, that process do not generate any kind of output. So second and third is incorrect process representation. Data flow represents what is flowing in the diagram. The data, what kind of data is flowing in the diagram is represented through the data flow. It is a path for data to move from one part of the system to another. Arrows representing the direction of the movement of data. It can represent flow between process and data store by two separate arrows. Remember, whenever there is a direction of flow, along with the direction of flow, the data has to be written. If the data is bidirectional, we should draw two separate data flow lines, and with each data flow line we should write the data. Remember that data name should not be a verb, it should be a noun. Payment detail, invoice detail, such kind of information has to be written on the data flow line. Can you tell whether this data flow line is correct or incorrect? Normally data is flowing after a process of activity. So from the store causes, without the process, the data will not flow to the student store or database without any process. So first one is incorrect. Whereas in second, the daily payment through that database process is happening through post payment, so data flow can happen to the database daily payments. Then from that database again prepare deposit is another process, so such kind of data flow is permitted. Second one is correct. Now this symbol data store is used in data flow diagram to represent the data that the system store. The system store label, the data store should be a noun phrase. Whenever we draw data store, there must have at least one incoming and one outgoing data flow. The concept is that the data which is to be stored should not be a waste of data. So there should be a system to give input to the data store. There should be a system to utilize that data which is stored in the database. That is why it expects one incoming and one outgoing data flow lines from the data store. So here you can easily understand which is correct, which is incorrect. First one is incorrect, second one is correct. Now source or sink, that is external entity, or generally we call it as entity. External entity is the origin or destination of data. The input will start from this entity. The final output will be to this entity, that is source or sink. It can be a singular form of a department or it can be a person. The label of this source or sink should be a noun phrase. Source means the entity that supplies data to the system. Sink means the entity that receives data from the system. Source or sink must be connected to a process by a data flow line. Can you tell which are the correct and incorrect diagrams? In the first diagram, payroll entity, payroll and department to employee, paycheck is performed, but there is no process. A direct data flow from payroll department to employee is not possible without a process. So first diagram is invalid, incorrect. Second is customer communicates to a process for the payments. Okay, it is possible. Then third, customer do the payment to the data store accounts receivable. It is not permitted because whenever a data store, whenever an entity needs a communication with data store, there should be a process. Only through the process this kind of communication is possible. So here the first and third diagrams are invalid, incorrect. Middle one, okay. So, in general, we can say some rules for using data flow diagram symbols. A process is to connect with another process, it is permitted. A process can be connected to external entity, okay, it can be permitted. A process can be connected to a data store, that can be permitted. Then there are some rules which cannot be permitted. For example, an external entity to another external entity, that kind of connection is not permitted in data flow diagram. An external entity to data store, which is not permitted in data flow diagrams. A data store to another data store directly through the data flow line is also not permitted in the data flow diagram. So in this class I am giving you this task. Find the errors, list the errors of this DFD, and you share the list of errors in this DFD through the WhatsApp group, so that others can also note. Uh, you can make a discussion, so that let us see how many of you can answer correctly, or how many of you can understand data flow diagram correctly. We will see this uh, after seeing this video. Okay, so please send your comments or share your errors that you have identified in this DFD through WhatsApp group. Okay, now we have discussed the various symbols and the rules to be followed whenever we represent data flow diagram. In data flow diagram, initially the system can be represented with context diagram. Context diagram is the top level view of this system. Context diagram represents the system boundaries. It represents the external entities that interact with the system. The major information flows between entities and the system can be represented with context diagram. This is a sample context diagram of order system. Order system that a company uses to enter orders and apply payments against a customer's balance can be represented with this type of context diagram. The various external entities like customer, sales representative, accounting, bank, warehouse are shown in the context level diagram of the order system. The major information flows between entities and the system is represented through the data flow lines. Whenever we draw a data flow diagram, context diagram is the first diagram, and we will get an overall idea, or we will understand what are the stakeholders or entities involved and what is happening, how the data is moving. The overall general picture can be identified, can be understood from the context level diagram of this system. Context level diagram and level 0 diagram are initial representation of data flow diagram. Actually, level 0 shows the system's major processes, data flows, and data stores at a high level of abstraction. Actually, level 0 DFD is the expansion of context level diagram. In context level diagram, there will be only one process, whereas here, more connections and more flows into and out of the process will be described. Actually, in level 0 data flow diagram of the order system, all the major submodules will be represented along with all possible entities. In context diagram, we do not describe the database, but in level 0 DFD, the database will be described, the different processes, important processes, the major modules of the system will be described, the data flow with more details can be described in level 0 data flow diagram. With each process you can see process 1, process 2, process 3, 1.0, 2.0, 3.0. Now the further expansion of this process can be done in the next level 1, level 2, level 3, etc. And thus the more details, sub details can be found for analyzing the system further. So data flow diagram is a functional decomposition activity or an iterative process of breaking a system description down into finer and finer detail. It uses series of increasingly detailed data flow diagrams to describe an information system. Balancing is important, that is, the conservation of inputs and outputs to a data flow process when that process is decomposed into a lower level is important. We have to ensure that the input and output data flows of the parent data flow diagram are maintained on the child data flow diagram. There are different strategies for developing data flow diagrams. Top-down strategy and bottom-up strategies are two different strategies for developing data flow diagram. In top-down strategy, it creates a high-level diagrams, that is context diagram, then low-level diagrams like level 0 diagram, then level 1 diagram, level 2 diagram, etc. will be written. Whereas in bottom-up strategy, it creates the lower level diagrams and then it combines and then into the higher level diagrams will be formed.